July's Hubble Challenge of 2025 is focusing on star clusters or globular clusters. And the first one up is Messier 13. It was found by Edmund Halley of Halley's Comet fame, and it is number 13, Messier 13. It was discovered in 1714. It is 25,000 light years away and in the constellation Hercules. Next up is Messier 92. It's a globular cluster and one of the brightest ones in the Milky Way, and it's 27,000 light years away. This one, too, is found in the constellation Hercules. It was discovered in 1777 by Johann Elert Bode. The next one is Messier 4. This one, you can use the bright star Antares to help you find Messier 4. This one is only 5,500 light years from Earth, and it's the closest globular cluster to Earth. It's also kind of interesting because Hubble made a discovery of a planet inside this globular cluster. And so because it's so close to Earth, it makes it a prime cluster for scientists to study, to learn about ages and how the stars work and the solar systems work. The next one in the lineup is Messier 62. This globular cluster has an extremely dense core of 150,000 stars in the constellation Ophiuchus. The astronomers have discovered a stellar mass black hole inside M62, the first one to ever be found in a globular cluster. The last one in the challenge for July for the Hubble Challenge is Messier 107. And the best time to spot this one is, of course, in July. It's 20,000 light years from Earth, and it's in the constellation Ophiuchus. Just like the last one. It was discovered in 1782. When I first got my sea star, I wasn't all that interested in doing globular clusters, but I've developed a fine appreciation for them. They are beautiful. They appear very quickly in the sea star. I'm using the sea star S50. They appear quickly, and then they just get better and better over time. You can just take one or two exposures and see them, but if you do image them longer and stack the exposures, they become clearer and clearer, and they're beautiful. It's easy to do the post-processing on these and make them even sharper, but these ones are straight off of the sea star. And I didn't make a note of how many exposures on each one, but these are from the Sea Star S50 for the July Hubble 35-year challenge. When I put them all up here together, you can really see the difference in them. When I'm imaging them, they kind of come up and they don't look all that different. They just look like a glob of stars, they're fascinating anyway, but when you put them up here together, you can see that they are very different. The globular cluster, the newer they are or the older they are, they get farther and further apart. So you see in the top left-hand corner one, that's a very young globular cluster, and the one just to the right of it is more spread out. Those are older. The stars move away from each other as they get older. And so it's kind of fascinating. Star clusters can be classified as open clusters or globular clusters, and it's dependent upon how tightly they are formed and how many stars or suns are actually in them. Anyway, thanks for watching. And like always, we're wishing clear skies to everyone.